Have you ever felt like you're just writing the same lines of code over and over and over again? It's one of the most common headaches in software development. Well, in this explainer, we're going to demystify a core programming concept called inheritance. It's an incredibly powerful tool that helps us write cleaner, smarter, and way more efficient code. All right, let's get into it.
Here's the game plan. We'll start by looking at the problem of code duplication, and then I'll introduce inheritance as the perfect solution. We'll see how it works in C#, explore the huge payoff you get with reusability, and then we'll uncover some of its hidden dangers before comparing it to another powerful design pattern called composition. So let's set the scene. The number one enemy of good software design is often just repetition. When we find ourselves copying and pasting code, we're not just saving a few seconds, we're actually setting a trap for our future selves. Okay, meet Andrew, a course director, and Sergey, a lecturer. Now, their jobs seem different, right? But look at how we'd represent them in code. They both have a name, an email, and a position. They can both teach and mark exams. The only real difference here is that Andrew has this special ability to write a curriculum. We've basically written the exact same class twice. And this is where the trouble starts. This whole copy-paste strategy creates an absolute maintenance nightmare. Let's say you find a bug in that teach method. You don't just fix it once. Nope. You have to remember to go and fix it in Andrew's class and in Sergey's class. It's inefficient, it's risky, and it completely violates a core principle of software design. Don't repeat yourself, or DRY for short.
So this begs the question, there has to be a better way to share all that common code without just hitting copy and paste, right? Well, thankfully, object-oriented programming gives us a fantastic answer. And that answer is inheritance. It's a concept designed to solve this exact problem of code duplication by letting us create these logical, reusable relationships between our different classes. At its heart, inheritance is really just about creating a parent-child relationship in your code. We define a parent class, also called a superclass, that holds all the common stuff. Then we create child classes, or subclasses, that automatically get all of those parent features. So you can think of the superclass as the main blueprint. Let's make a general person class. We'll put all the common properties like name, email, and position right in there. We can also add common behaviors. Let's say everyone at the university can introduce themselves. We'd write that method just once, right here in the person class, making it our single source of truth. Now the subclass, the child, gets all of that for free. A lecturer class can inherit from our person class, and then we just add its own specific abilities, like teach and mark_exam, see? The child class gets the best of both worlds, all the reusable code from the parent, plus its own unique powers. Now here's a super simple mental shortcut to know when inheritance is the right tool for the job. It's called the is-a test. If you can say one class is a or is a kind of another class, then you've probably found a great spot for inheritance. A lecturer is a person. A course director is a kind of person. See how that works? It's a simple test that tells us we're on the right track. Okay, so that's the theory, but how does this actually translate into real code? Let's jump into a practical example using C#. The syntax is surprisingly simple. We define our person class just like we normally would. Then, when we define the lecturer class, we just use a single colon followed by person. That's it. That one little character tells the compiler that lecturer is a child of person, and boom, it instantly gains all of its public and protected features. Now, for this to work, we have to talk about access. The protected keyword is the real hero here. If a property in the parent is public, anybody can mess with it. If it's private, nobody outside the class can touch it, not even its own children. Protected is that perfect sweet spot. It keeps the data hidden from the outside world, but it allows the child classes to access and use it. It's kind of like a family secret. So we've set up this whole hierarchy. What did we actually gain from all that? Well, let's look at the incredible payoff we get from designing our code this way. The benefits here are massive. We write way less code, which speeds up development. If we find a bug in a method inside that parent person class, we fix it in one place, and that fix is automatically inherited by the lecturer, the course director, and any other children we create. Our code is easier to test, and it becomes incredibly easy to scale. What if we need to add a student or an administrator? Simple. We just create a new class that inherits from person, and it's already got all the basic functionality baked right in. But, and this is a big but, inheritance is not a silver bullet.
It is an incredibly powerful tool, but if you use it the wrong way, it can create just as many problems as it solves. So we really need to understand the risks. As we get deeper, it's really important to clarify two terms that cause a lot of confusion: overriding and overloading. Now, overriding is a key feature of inheritance. It's when a child class provides its own, more specific version of a method from its parent. So think of a bird class that has a move method. A penguin class, which is a child of bird, would override that move method to mean waddle instead of fly. Overloading, on the other hand, has nothing to do with inheritance. It's simply having multiple methods that share the same name but have different parameters. Getting these two mixed up can lead to some tricky bugs, so it's a really critical distinction. The biggest danger of inheritance is something called tight coupling. The child class isn't just using the parent, it's fundamentally tied to the parent's internal plumbing. Imagine changing the engine design in a car factory. All of a sudden, every single car model built around that old engine, the sedan, the SUV, the sports car, they might all just break. That's what we call the fragile base class problem. A tiny change in the parent can send a shockwave of bubs down through every single one of its children.
Because of these risks, it's crucial to know that inheritance is not your only option for reusing code. There's another powerful and often much safer pattern out there called composition.
This brings us to a really fundamental design choice. We use inheritance for is-a relationships. A lecturer is a person, but for has-a relationships, we should use composition. Think about it. A lecturer doesn't become an email service just to send a message. A lecturer has an email service that it uses. Composition lets us build complex things by plugging together smaller, independent components, almost like building with Legos. This has-a relationship is so much more flexible. It completely avoids that tight coupling problem we just talked about. And this leads to a famous mantra in the world of software design: favor composition over inheritance. It encourages us to build robust systems from interchangeable parts, rather than locking ourselves into a rigid family tree.
All right, so to wrap it all up, inheritance is our go-to solution for code duplication, but only when we have a clear is-a relationship. It lets us define common code in a parent class for all the children to reuse, but we have to be really careful about the risks, like that tight coupling. For pretty much everything else, especially for has-a relationships, composition is very often the safer, more flexible, and better choice.
And that leaves us with one final powerful question you should ask yourself every single time you're designing your code. Before you create that parent-child link, just stop and ask, is this object truly a kind of the other thing, or does it just need to have the other thing's functionality? Answering that one question will guide you to a much, much smarter design.